Hi there. This video is going to go up on a Tuesday. It's the lesson for Wednesday, and in it we solve the problem of the very lazy coach, and we're also going to talk about explaining the answers to the one pair thing, and we're going to pose another question. Okay, so that's what we're going to do. All right. First off, the very lazy coach had 14 kids, right? And in the wintertime, the very lazy coach is a basketball coach, and he's got to put 5 of them out on the court, but does not spend any time with positions. Hence, we are not dealing with permutations, we're dealing with combinations, but you probably knew that. Since you hopefully now know about the notation for this problem, we could look at it simply this way. And you can put that into a machine and go ahead and answer it. And if you do the same thing when the very lazy coach is a baseball coach, you'll answer it this way. And you can put it out into a machine and answer it. Well, I put both those into a machine and answered both of them and got a curious result. Hope you got it too. That curious result is this. Let me just see if I can hold that there so you can actually see it. Yeah, I'm trying not to get glare on there. 2002 was the answer for the number of different ways to put out a random basketball team. And 2002 was the number of ways to put out a random baseball team. Does that seem curious that these two questions have the same answer? Well, the reason why I chose 14 athletes was so that would happen in those particular sports. So what it amounts to is this. When the coach goes into the dugout and says, let's see if I can keep this straight, I'm having a hard time counting lately. You, and you. Get out there, find your positions and play. That coach also could have said, all right, everyone's going to go out there and play except for you, and you. So if the coach chooses 5 players to leave in the dugout, the other 9 take the field. If the coach said to his basketball team, you 9 players stay on the bench, everyone else go out there and play. That's no different a problem than saying you 5 go out and play, everyone else stay on the bench. And that's why 14 choose 5 is the same as 14 choose 9, because 5 plus 9 equals 14. Now, when you look at the mechanics of the formula here, 14 factorial divided by 9 factorial 5 factorial, or 14 factorial divided by 5 factorial 9 factorial, that denominator doesn't matter because multiplication, as you well know, is commutative. So that's the very lazy coach explained. Now, our 6 parts of our numerator to our how many ways to get one pair, that number that comes out to be something. The 59,900. No. See, I always lose this number. It's up there. It's 110 million, just about. 109. Nope. There it is. It's 109 million something. Shouldn't take that long to find it. 109 million 800. Nope. Again, 1,098,240. All right, where that's coming from? That was this thing right. I want it to be right here, right there. Here you are. Okay. That was 13 choose 1. Was we're going to have either a pair of aces or a pair of kings or a pair of 7s or a pair of 3s. So of the 13 different ranks, we're going to choose 1 to be our pair. Now to get the pair, this next one is, there were 4 different cards. So let's say we're going to have a pair of 7s. Well, there's spades and hearts and diamonds and clubs, and we have to choose 2 of those. That's why you have 4 choose 2. Now, there are 12 other ranks in the deck. So we're choosing, of those 12, we're choosing 3. And of each of those 3, we got to get 1 of each because they can't match. So we have to have 4 choose 1, 4 choose 1, 4 choose 1, because there are whatever 3 of the remaining 12 we grab, we have to grab 1 of the 4 of those suits in order for that to work out. Now there's 13 choose 1, that's 13. 12 choose 3, that's a bigger number. All right, 4 choose 2, that equals 6. At least it should. 6 different ways to choose 2 things out of 4. Because the order doesn't matter. So 4 times 3, but then that which is 12, you can flip those around because the order doesn't matter. So you divide by 2 because there are 2 different ways to do stuff, and that's how you get 6. So 4 choose 2 is a fancy way of saying 6. 4 choose 1 is just 4. So that's what that numerator was, and that's where you get that big value on that one. So here now is the challenge going forward, all right? When we did the card thing, again, we had 2,713 hands that were dealt out. 10 of those were full houses. And remember, a full house is 3 of a kind and a pair. Your job is to try to use this structure, okay? You can use the other one if you like, but this structure if you can, to figure out were those 10 more or less than we would have expected. So the real question is, find the probability of getting a full house and then multiply that by 2,713 and calculate how many full houses should we have expected out of that number of 5-card poker hands. We actually got 10, so did we get more than or less than we were expecting? Use that same kind of structure, all right? So what you're going to do here is, of the 13 different ranks that exist, you're going to choose, I'm going to let you work on it, all right? And then that answer will be up around the bend. All right, thank you very much. Hope things are going well. If you have any questions, I'm available in the chat and some other stuff. And this is going out on Wednesday, and I got to decide if we are meeting on Thursday or not. And I'm going to decide, because I'm shooting this earlier in the week, so there will be, let's say yes. And then we will sort out, I'll probably change my outfit. It'll be in the end of this video, I bet. Who's meeting on Thursday to share some stuff? So I'm back, not with groups, but you can forward to some other point in the video right there, to get who the groups are for Thursday and the times and stuff, okay? That's going to be kind of wacky, but we'll take care of that in a bit. This is called the Heavens, and I just want to see how it sounds with this little microphone I got going on. So hope you enjoy it, and if you don't, just forward ahead. So here we go. When I look at Venus, I think of you and things we used to say. The secrets between us, the lies that came true, and what got in the way. When you look at Saturn, do you think of me and places we would go, and dream of the patterns of how things could be, as if we didn't already know? I only now realize I can look to the skies. That's where I recognize what I once saw in your eyes.